Hey everyone. Um, Here we are. We're gonna finish up with section 9.6 today, or we're gonna start 9.6 today, which is solving nonlinear systems of equations. Okay, so we have solved linear systems of equations before, but we've used like elimination and substitution to help us do that. Now we're gonna move on to nonlinear systems of equations. Okay, so a system of nonlinear equations is just, again, it's a system, aka two equations, at least two equations, I should say, in which at least one of the equations is nonlinear. So most of them that you're going to be dealing with are probably going to be quadratic. You might have an exponential or two, but not many. So for the most part, we're going to be dealing with quadratics, basically. So the first thing I want you guys to know is that I am going to, like if you look at this next example here, it says solve the system by graphing. If you want to use Desmos to help you graph these, go ahead and do that. I'm totally okay with using Desmos for now. Just make sure that you understand how to graph quadratics. That's a really big concept, okay? So I actually have already kind of gotten Desmos started. So I started by graphing our first system, which is 2x squared plus 5x minus 1. So if you notice, the axis of symmetry is right here between -1 and -2. And then, so that vertex, okay, so the vertex is at -1.25 and -4.125. So there's the vertex. It crosses here at 0, -1. But now what we want to do is we want to plug that second equation in. So if I just go back to this, we want to plug that y equals x minus 3 in. So I've got I don't need the y there. I just need x minus 3. Okay, so here's our second equation. Again, that y-intercept is at -3. Your slope is up 1 over 1. What they're basically trying to get you to see, you guys, is where are these two lines intersecting? At this one, it's intersecting at the point -1, -4. So we would say that our solution for this system is going to be at -1, -4, because that's where they intersect. Okay, just another quick thing, you guys. When you have things that have one solution, it's saying that they just intersect at one point, like this system of equations does right here. You may also have no solution. So that means that you would just have like your quadratic over here and then your linear over here. These two never intersect, so that means that there would be no solution. And then the last one is that there might be two solutions. So let's say you had your quadratic and then your linear intersected twice. You would have two solutions. One solution right here and then one solution right here. Okay, so if you want to do all of this by hand, I know I gave you a couple of graphs here down on the bottom, but if you want to just solve the system by graphing using Desmos, I'm absolutely okay with it. Like I said, just make sure you understand how to graph a quadratic. That's really the big idea. Okay, so you might have one solution, you might have two solutions, and you might have no solutions. And I am, once again, totally okay with you going to Desmos and using Desmos to help you out with these. All right. The last thing that I'm going to talk about today on this video is using substitution. Okay, we started solving systems using substitution and elimination and graphing, but they were both linear. Okay, now we've got one that's quadratic and one that's not quadratic. And if you think about substitution, remember, we want there to be one variable. Wow, that's really bad. All right, you know, whatever. We just want there to be one variable that is isolated. In this instance, we actually have both variables that are isolated, which is awesome. Okay, so what we're going to do, how we're going to solve these is we're just going to take, since you have y equals y, we're just going to take these two pieces and set them equal to each other. So we're going to take x squared plus x minus 1, and we're going to set that equal to negative 2x plus 3. And from here, get everything over on the one side, because now you just have one variable that you're dealing with. Let's add 2x. Let's subtract 3 and have everything together on one side. So x squared plus 3x minus 4, now that equals 0. Now you can use any one of your methods to help you finish solving this. Factoring, graphing, using square roots, completing the square, using the quadratic formula, any one of those 5 methods to help you solve this is totally cool. For me, I'm kind of looking at this and I'm starting to think about my factors of 4. I got 1 and 4, 2 and 2. I absolutely can factor this. So I'm just going to start by factoring this. I'm looking at this 4, so I'm thinking that it's got to be 4 and 1. And then I've got to look at this sign here, so that's got to be positive, that's got to be negative. Now I'm going to set x plus 4 equal to 0. I'm going to set x minus 1 equal to 0, and I'm just going to solve. Here I've got x equals negative 4, and here I've got x equals 1. And I'm good to go. Those are my solutions. Okay, so now your job, you guys, is to go through. I want you to do 1 through 3, and maybe you've already done that because maybe you had paused the video and did it. But I also want you to go through, I'm not going to do the elimination right now. We'll do elimination in the next video. But I want you to do 4, 5, and 6 using substitution. Notice how y is isolated in all 3 of these, so it's just a matter of solving. Okay? If you've got questions, make sure you write them down, and then you will have time tomorrow to ask whatever you need. Otherwise, this is the end of the video. Pretty quick. Whoopsies. That's my grad school assignment. All right. If you got questions, let me know. Otherwise, I'll see you guys tomorrow. Have a great night.